In this lesson, we're going to solve radical equations by using this fact here. If x is equal to y, and you square both sides, the result should be equal. So in example 1, I'd like to solve this equation. The square root of 2x plus 1 is equal to 5. And the method is to take both sides of this equation and square it. If these two things are equal, then certainly the square of those two things must be equal as well. The reason this method works out great for this problem is the square root of something squared leaves you with just what's underneath the square root, which is 2x plus 1. And on the other side, we have 5 squared, which is 25. The root is now gone, meaning you can solve this pretty easily for x. I will subtract 1 from both sides, and then divide both sides by 2. And here I have my answer, that x is equal to 12. And it might be a good idea to check to see why this value actually works. So here I'll just, off to the side, check my answer. So I will put 12 in place of x and ask if this is equal to 5 when I'm done. Okay, let's see. Well, I can see this is going to work. We have 2 times 12, which is 24. If I add 1 to 24, I get 25. And the square root of 25 is, in fact, 5. So certainly x equals 12 is a solution when you plug it back into this equation. Perfect. So this is my solution. There is one thing to look out for with this process. When you square both sides of an equation, you may introduce numbers that do not work in the original equation. To see what I'm talking about, let's look at an example. So I want to look at the square root of 2x plus 1. We'll start with the very same equation, but this time I'm going to let it equal negative 5 instead of positive 5. So almost an identical equation, I just put a negative on this side. Before we even solve this, there is no way this equation has a solution. The square root of anything is always a positive number. It can never be negative by definition, so there are no solutions. But let's see what happens if we square both sides of this equation, so that it is on the left, and on the right, I'll raise both sides to the power of 2. On the left, you still get 2x plus 1. The reason is the square root and squared cancel. And on the right, negative 5 squared is still positive 25. If you subtract 1 from both sides, and then divide both sides by 2, you get a solution. You get x is equal to 12. But if you plug that back into the original equation, it's not going to equal negative 5. We already know it's going to equal positive 5. So we call this thing an extraneous solution. It is something that comes out of this process. It just does not work in the original equation. So we throw this one away. But this is why it'll be important for us to check our answers. If we ever get an answer, it's worthwhile plugging it back into the original equation because sometimes you'll get an extraneous solution, but sometimes you won't. Let's see what happens in example 2 where, again, we're solving this equation that has a square root in it. So the goal is to, at some point, square both sides because if you square a square root, they cancel. However, this square root is not by itself. So what I'm going to do is I'm going to add this to the right side of the equation, and I'm going to subtract the x to the other side. So just a little bit of setup work here, but my first step is, well, I'm going to add this to both sides. I get 5 is equal to x plus the square root of x minus 3. But then I'm going to subtract x from both sides. And I get 5 minus x is equal to the square root of x minus 3. I don't need that plus sign in front of it. So here's a first step where, okay, before I square both sides, I want to make sure that on one side I have the square root completely by itself and everything else is on the other side. It's at this point where I can say, if these two things are equal, then the square of these two things must be equal as well. On the left, we get 5 minus x squared, whatever that is, but on the right, the square root squared is just x minus 3. So here's my goal. I want to square this thing out and somehow solve that resulting equation. Okay, so let's see. What is 5 minus x squared? Well, that's 5 minus x times 5 minus x. That still is equal to x minus 3. I have to be careful to use the distributive property here, where I multiply in the 5, as well as the negative x. 5 times 5 is 25. 5 times negative x is negative 5x. Negative x times 5 is also negative 5x, but negative x times negative x is positive x squared. All right, I can combine some like terms. On the left, we have 25 minus 10x plus x squared. This is a quadratic. My approach is going to be, all right, I'm going to subtract these two things to this side, so this side is equal to 0, and perhaps I can factor what's over here on the left. Let's see if that happens to work. All right, so I'll subtract x from both sides. I get 25 minus 11x plus x squared is equal to negative 3. And I guess I will add 3 to both sides. I get 28 minus 11x plus x squared is equal to 0. And I got to rewrite this. I don't like thinking of it this way, where I'm going to take this whole thing, I'm going to put the x squared first, then the 11x, and then the 28. I want to solve this thing for x. Let's just pause for a moment and say that, well, we started with a square root, we squared both sides, and we did change the equation. There's no root in it, but there is an x squared, and we have a method to solve this thing. Our method is, can I somehow factor this into two pieces and see where each individual piece is equal to 0? I'm going to try to guess. Okay, it has to be x minus and x minus. I need two numbers that multiply to positive 28 yet add to negative 11. That's got to be 7 and 4. So this means that either x minus 7 is 0 or x minus 4 is 0. If I add 7 as well as add 4, these are my two solutions. Took a while to get there, but here it is, 7 and 4. But here's where I want to be careful. It might be that one of these is an extraneous solution and the other is not. So I'm going to go back to my original equation. I'm going to plug in 7. I'll then plug in 4. If one of them does not work, I'll throw it away. Let's start with 7. 5 minus the square root of 7 minus 3, is that 7? Is this true? Okay, that's 5 minus 7 minus 3 is 4. And that's 5 minus 2. Is that 7? No. This is no good. What this tells me is, in my original equation, x cannot be equal to 7. That's no good. But what about 4? Let's check that one. All right, if I try 4, that's 5 minus the square root of 4 minus 3 is equal to 4. So 5 minus the square root of 1, we're asking, is this true? And well, the square root of 1 is 1, and 5 minus 1 is 4. So this one actually did, in fact, work. Nice. So what this means is x equals 4 is a solution. It turned out that x equals 7 was not. So that means 4 is the only solution to this original equation.